Do you remember our video on ionic compounds? Some compounds bond by forming charged ions, which are then attracted to each other. They form non-directional bonds, which means they can build up giant structures with lots of bonds between ions. These structures often dissolve readily in water to give free ions. In an equation, we represent those ions like this. AQ, or aqua, means dissolved in water. Each ion is surrounded by a sphere of polar water molecules, the slightly positive hydrogens near negative ions, and the slightly negative oxygens near positive ions. Solutions are good media for ionic reactions to take place. You could have a salt dissolved in water and combine it with a solid metal. If the salt cation is more reactive than the metal, nothing will happen, but if the metal is more reactive than the salt cation, they will react. The reactivity series shows which metals are more reactive. For this reaction, let's use copper sulfate solution and zinc metal. Zinc is more reactive than copper. What is going to happen? Notice that this reaction takes place in solution. The metal ions and sulfate ions are split up. We can rewrite this equation omitting the sulfate ions, because these do not take part in the reaction. They are a special kind of counterion called a spectator ion. These kinds of reactions are used in electrolytic cells. Either energy is supplied to electrolyze systems and make them go in the wrong direction, producing very reactive metals pure, or the reaction is allowed to go in the natural direction. Energy is released and used to drive electrons round a circuit. The reaction between copper sulfate and zinc metal occurs in the Daniell cell. If we want to look at just zinc or just copper and what happens to that metal, we can even write the reaction as a sum of two half equations, introducing free electrons which cancel if you add the equations together. According to Rig, oxidation is loss of electrons, reduction is gain of electrons. Which species is reduced and which is oxidized? Pause the video for a moment to think. Zinc loses 2 electrons and copper gains 2 electrons, so the copper ions are reduced and zinc metal is oxidized. Did you work that out? Some ionic reactions do not involve reduction or oxidation, but involve swapping spectator ions, like this. In this reaction, the potassium and nitrate ions are spectator ions. When the metals carry different charges, they may need balancing. Can you balance this reaction between copper metal and silver nitrate solution? Pause the video for a moment whilst you think. You will need 2 silver nitrate species for every copper species. Because copper is most stable in the +2 oxidation state, we can also write this omitting the spectator ion, Na3-. Remember to balance the charge as well as the elements on either side of the equation. Let's go through a slightly more complicated example. Magnesium metal reacting with acid. In this example, we only need the H+ ion from the acid. The anionic part is a spectator ion. Balancing this equation is really simple. Just double the number of H+ ions and everything balances. Can you write the half equations for this reaction? Pause the video again whilst you work it out. Got them? By now you should be comfortable writing ionic equations and ionic half equations. You should understand how a salt dissolved in water to give aqueous ions, and be able to use the reactivity series to decide whether a reaction will go or not.